data. What was the problem that I tried? Prices and quantities. Yeah, there was something. What was the deal with prices and quantities that was causing an issue?
GDP is determined by price and quantity, but we mostly just care about quantity.
All right, we mostly just care about quantity. In fact, we can argue that we only care about quantity. You know, one way to think about this, that as we start to develop this more, is if the price of everything on the shelves at Walmart, every single thing at Walmart, every single price, if all of those doubled, would you care?
Yes.
I hear a lot of yeses. Now, if everything on the shelf at Walmart doubled and so did your income, would you care? No, you can buy the exact same amount of stuff that you could as long as your income doubled too. So that we've got the price of resources as well as the price of output, the final goods and services. Both of those are affected through inflationary pressures and tend to rise over time. They can rise at different rates, and that's going to be a hot topic for us later on in the semester of thinking about the differences and how they might change. So for right now, we're just trying to get a fix on how to measure those changes. Let's see, I need some of your help here. I don't think I'm going to do every column on the table, but I made up some of the numbers. 1, 2, 3, 4, 5, 6. And let's go with our GDP number. What did we have for one? If you got them all right there? Why don't you give them to me? Just
335.
335.
405.
405.
555.
555.
536.
536.
598.
598.
And 663.
663. All right. So we had some columns in between. If you guys weren't here, you need to get the notes from your neighbor here of prices and quantities. So I had two goods, two hypothetical goods, good 1 and good 2, and we added them up to calculate real GDP using our formula of the sum of PI times QI for I equals 1 to N. That simple equation simply meant take the price in good year 1 times the quantity of good 1 plus the price of good 2 times the quantity of good 2. Let's do that for each of the years. So if it was 2011, take the prices of 2011 times the quantity of 2011, and we get GDP for 2011. That's all we did, filling in that table that you guys already have on your papers if you were here. If you weren't here, then make sure you get this down and review the tapes. I think I posted the macro lecture from last time where you can check it out. All right, so this ends up being a mixed bag of things. So if we look at, let's call this 2005. So let's just say 2001 through 2005, just to keep numbers nice here. So what was the percentage change in GDP for 2005? So let's start there. Today, which is different than what we started with last time. What was the percentage change in GDP in 2005? Yes. So, and that's why I worded it that way. So, when I give you guys a statement like this, remember last time, what did I ask you for? The growth over what time period? 2001 to 2006. So you guys had that same formula. If instead we give you a question like this, where what is it for 2005? Implicitly, we're just talking about 1 year to the next. So from one time period to the next. And so if we're talking about 2005, we're going to put that new number minus the old number divided by the old number. 2005 minus 2004 number divided by the 2004 number. So go ahead and calculate that out. So our formula for percentage change in this class, percentage change in variable x, is we take the new number minus the old number divided by the old number. And what do we get for this one? 11.5%. Okay, so for 2005, we're going to take 598 minus 536 divided by 536 gives us, now that gives us actually, if you put that into your calculator, what does it really give you? What's the actual number? 0.115. I just wanted to highlight that part. Now, in order to make it a percent, what are we technically doing mathematically to convert that to a percent? Times it by 100. So this formula up here, the percentage change in x is new number minus old number divided by old number, and I just kind of conveniently left off an important part of the formula is to multiply by 100. And that's just shifting that decimal place over a couple spots so that we can call this 11.5%. All right. So what we just calculated is called nominal GDP. So put a little n in front of that. So nominal GDP has, I think my little cameraman is following me with come here. Yeah, it must be a little sad today. Okay. Well, actually, I'm getting kind of hot anyway. It might be this jacket, I guess. Hangs over. All right, so nominal GDP is gross domestic product measured in current year prices. So current year prices, oh, yes, now I got to put that back on. Which is exactly what we did. And the problem is that we're going to get a mix of prices and quantities. All right, so nominal GDP, nominal gross domestic product, nominal GDP, NGDP, is measured in current year prices. Now, I don't even like that word, current year prices, but that's how your textbook, and it's kind of common language. It's the year in which we're measuring. So, for example, the equation that we just put out here for 2011, we're using 2011 prices and quantities, and that's just our notation we use. So, nominal GDP for 2014 is equal to the sum of all prices of all goods and services measured in 2014 prices and quantities. Now, last time, who was it that came up with the average technique? Was that Brendan? Is that you? The averaging the prices deal? Okay, so that's where we left off last time, is that this has a price effect and a quantity effect all jumbled up inside. We know that it went up by 11.5%, but are we 11.5% better off? Well, what we learned last time is that if prices all went up by 11.5%, but we don't have any more stuff, then we're not better off. It's the stuff we care about. We care about what our money buys, and so having prices go up only is not what we're looking for. We want more quantity. All right, so instead of using the Brendan method, which is not wrong to help solve that problem, we've got a different technique. So now I want Brendan to pick whatever year you want, 1, 2, 3, 4, 5, 6. Since you had your neat idea of fixing prices, I'm going to do it a little bit differently by using what we call a base year. And we're going to base all of the calculations off of that year. So you give me whatever year you want, I don't care. 3. All right, so we're going to call year 3 the base year. And recalculate what we call real GDP in the next column over. And real GDP for 2014 is equal to the sum of all n goods. So nothing's changed so far here, PIQI. But we're going to use the quantities in year 14, but the prices in the base year. So now we're going to, let me put a little flash of color here. We're going to use the base year now to recalculate all of our numbers. So you remember we had 1, 2, 3, 4, 5, 6. You remember your number that you did before? Let's do the same thing. You guys recalculate all of the numbers using year 3 as the base year. So you're going to have prices in year 3 for each of the quantities, and we're going to recalculate real GDP. Now, if you're understanding what's going on, you people in row 3 should have some quick answers for me. As soon as you got an answer, whatever row you're in, give me your answer and I'll write it down and then we'll double check our work. Remember, I haven't prepared this ahead of time, so I don't know what the right answers are. We got to kind of work together on this.
Well, isn't ours just the same?
Ah, there you go. Good job. Yours is the same. That's why I was looking for a quick answer. So you were quick on the draw. So yes, real GDP is the same for the base year. 555.
455.
For which one?
1.
Year 1? 455. 539 for year 4. $681 for year 6.
445.
445 for 2. And we got year 5. How are we doing, folks? Who's got an answer for year 5? One, 2, 3, 4, 5. Now I know who I'm looking for. Jason, this is your row. We need year 5. And it doesn't have to be Jason. Who else is over here? We got people with calculator dysfunctions. What's your brain dysfunction? Let's help you out. So you're going to use 11 times 24 plus 9 times 26. So you're basically going boom times boom and boom times boom. What'd you get? 487? So we got a contender here of 487 for year 4. Which one is it? Did we get some other support? 487, I got a second. And a third? Okay, if we're up to 3, I'd say we're doing pretty good. All right, so 487. Double check all these other numbers too, folks. I don't have the answers. Yeah. 507 for 6. Okay. Well, maybe I should have asked for a second on that. Somebody else check Gabe's work here. Is that a second? You got number 5 figured out?
Yeah,
498. So I'd like to get seconds for all of these.
Second Gabe, 507.
You second the 507. Check. Okay.
498.
498 is seconded. All right, so we got a pretty good set of numbers now. So we got 455, 445, and you can see how these numbers look a little bit differently now. So what is the percentage change in real GDP? Let me write down real GDP first here. Real GDP. My green is not very bright here. Real GDP. So the real part of real GDP is that it's measured in base year dollars. Measured in base year dollars. And what is real GDP growth in 2005. So what is real GDP growth in 2005? What are we getting there?
-7.6%.
Negative 7.6%. That is not correct.
Oh, my bad. I wrote down the old number.
Okay.
We changed it.
Yeah. Once I heard the negative, I knew we were not quite there.
My bad.
That's all right. What'd you get? Did I hear somebody? 2.2%. You guys get that?
Okay.
So we've got real GDP, the percentage change in real GDP, that variable is equal to 498. Make sure you guys are tracking with this, minus 487, divided by 487, times 100, 2.26%?
Yep.
All right. Are we seeing it? I like hearing those O's like that. The understanding sinking in. Okay, so notice what we did. We froze P, right? Prices are froze at the base year. So now we're really getting the change in quantities. We're getting a reflection of the percentage change in quantities, which is what we were looking for. This is what we call economic growth. When you guys hear on the news that the economy grew by 2.3%, that's this variable right here. This is the one. Real GDP grew by 3%. So our key takeaway here is that economic growth, when we hear economic growth, quote unquote, is percentage changes in real GDP. Now, the news media is not adverse to screwing that up sometimes. They might use this variable, which changed by what? What was our answer here? 11.5. So there's a pretty big price effect, right? So if we say the economy grew by 11.5%, you're telling a completely different story compared to the economy grew by 2.2%. Right? So we want to filter out that price effect. Okay, any questions on that so far? Yeah.
Did we just arbitrarily choose the base year, or is there a method in how to choose a better base year?
Arbitrarily chosen.
Okay.
Yeah, we'll talk a little bit more about that, but the base year is arbitrarily chosen. The actual technique that's used, we don't get into the mathematics of that, but it's not too much different. It's kind of a moving average of prices. So it is in your book if you want to look. It's called the chain linked index, and that gives you a real look at how it's actually calculated. But conceptually is what I care about. I want you guys to conceptually got it down that we freeze prices and we only care about the quantities. All right. So our next thing is to capture that price effect back. So we've got another technique to capture the price effect back. How many of you have heard of the CPI? The CPI. CPI? You know what it stands for, Austin? Consumer Price Index. Okay, so that's measuring prices. So that's what kind of comes out of this, is an ability to map out the price effect as well as the quantity effect. Quantity effect is right here, but now we can kind of backdoor our way into getting the price effect as well. And so that is called the price index or the price level. So PL is going to be our next column. And maybe I'll put some text down here. So next, we can calculate the price effect by creating an index number. An index number called the price level. the price level, which I'll use the notation P subscript L, price level. So that's this next number we're going to look at. The price level is the ratio of nominal GDP and real GDP. So all we're going to do is take nominal GDP divided by real GDP. And then we're going to slide it over a couple spots too. We're going to multiply that by 100, but it's not a percentage deal this time, as we're going to learn. So get back into your rows, start calculating the price level for rows 1 through 6. As soon as you get an answer, tell me what it is. My row 3 people should be quick on the draw again as soon as you get the understanding of it here. We're going to take the ratio of nominal GDP to real GDP. You are not 1. You're close. 100, just because of the 100 thing. We're just shifting that decimal place over a couple spots. So my base year, people, is 100 is the index number. Everybody else is going to have something different.
130.76.
For year? For 6. Say it again.
130.76.
Okay, yeah, let's go to 2 decimal places.
I second that. I second that as well.
We got a second. I didn't hear. What did you guys get?
73.63.
73.63. So you guys in the base year, I wouldn't sit on your haunches. Go ahead and pick another year and start double checking work. What else we got? Yeah. 120.08. That was for 5. 120.08. 91.01. Okay. And we're left with year 4. What are you guys coming up with year 4? 110.06. Do I hear a second on that? Sound good? I see some heads nodding. All right, so there is our price level numbers. All of them are centered around the arbitrarily chosen year, the Brendan year of year 3. It could have been year 5, it could have been, right? Leaves 100, that's our benchmark. And all we're really measuring is how did prices change relative to the base year. That's why we call it the base year. We're basing all the other calculations on the base year. All right, so inflation. There's a word we haven't mentioned yet. What was inflation in 2005?
Would that be the difference?
It's not just the difference, but you're on the right track. So we call it technically, if we're not sloppy, we call it the inflation not ratio. Rate. The inflation rate. So it's a percentage, so we're back to doing what we did before, right? It's the rate of change of prices. The rate of change of the average level of prices is inflation. So that's our next goal here is inflation rate. The inflation rate is equal to the percentage change in that price level. New number minus the old number divided by the old number. So, and I'm going to use the symbol pi for inflation. I know sometimes that screws people up that had me for micro because pi was profits. But now we're in macro class, so I have the right to switch that around. So we're going to use inflation as pi, the symbol pi. And so what is the inflation rate for 2005? How much? 9.10%. Okay, so we got new number minus old number divided by old number again. So 120.08 minus 110.06 divided by 110.06 equals, say it again, Sawyer?
9.10%.
9.10%.
I will second that.
Second. We have a second. All right.
No problem. Got your back.
All right, so we have a first and a second. Sounds like we're on the right track. Looks like it. And I kind of know that we're at least close. Because what was the overall change in nominal GDP? The very first percentage change we calculated. 11.5, which was composed of a 2.2% change in quantity and a 9.1% change in price. So I knew we were close. By the way, that doesn't end up adding up perfectly. It depends, because there's a little bit of rounding and some other things going on. But conceptually, that's what's going on, is we've decomposed the price effect and the quantity effect by creating this index the way we did. All right, so let me get one thing here down, and then I'll come back to you here. So note, assume an annual rate unless otherwise stated. I didn't want to forget this. Assume an annual rate. So when I said, what is the inflation rate for 2005? Again, we just went back 1 year. There's nothing wrong, though, with like what we did before. In fact, let's go ahead and do it. What is the average level of, what is the inflation rate from 2001 to 2006? Go ahead and calculate that out for me, because we did that for GDP, and we kind of had a big number for nominal GDP. And this is where the numbers will be a little bit further away. When we get there, it's going to be a big number. 77.5, let's call it 77.6%. So new number, 130, minus old number, 73, divided by the old number of 73. That'll give you the percentage change over the 6-year time frame, right? So you can do that, you can apply that same logic to calculate the inflation rate, the average level of change over the 6 years. But I would ask you for that in a homework problem or a test, specifically that we're departing from the norm, which is an annual rate. 77.6 roughly. Got something different? So 130 minus 73 divided by 73, roughly. You got a second? Okay, we got a second on the 77. So it should go there to there. All right, what was your question?
Right. You said
did that answer? Okay.
You said that it doesn't necessarily add up. Is that exclusively because we rounded? Like, had we not rounded the numbers, would they add up to each other?
No, there's a little bit with the new number and the old number, depending on if you're going up or down. Anyway, it's a good rule of thumb that they should map out. Yeah.
All right.
All right, anything else? Okay, so so let's get into what these numbers are called. So we got different types of price indices. The exercise we just went through can be used for darn near anything. I mean, there was nothing special, right? I just had arbitrary good 1 and good 2. When we use actual data from GDP and we calculated it the way we did, it's called the GDP deflator. So different names, let's just put different kinds of price indexes or indices. Different kinds of price indices. Number one is called the GDP deflator. So this uses what we did, uses nominal GDP and real GDP to calculate it. Another price index is called what, Austin? The consumer price index. That's a little bit different. So the consumer price index, the CPI, which is one of the most widely watched measures, the CPI uses a basket of consumer goods. Of consumer goods purchased by the average there is such a thing, the average household. GDP is how many goods and services in the nation? All goods and services, all final goods and services produced within the nation's boundaries over the course of the year. The CPI is just a subset of that, so it's a smaller basket of goods. All right, we'll come back to that one in a bit. Another one is the, well, there's a bunch of them, but let's call it the Producer Price Index. It's really just to kind of let you know that there's a number of different ones out there. The Producer Price Index, the PPI, measures wholesale prices, and sometimes called the Wholesale Price Index. And I take that back. Producer Price Index is resource prices. So this one uses a basket of input prices. And then there's a wholesale price index, and there's lots of different ways. Again, the math all works the same like this. It's just how many goods we're looking at and what type of goods there are. Okay, so let's look at what's in this basket. So what does the CPI basket have? The CPI basket, we've got one category of housing. So housing makes up 42% of the average household spending. Number two, transportation. In that category, we've got 18%. So items in that part of the basket represent 80% of the spending. Food and beverage. Food and beverage runs about 15%. Medical care. We know that that's been going up. In fact, this data is a little bit old, but it's roughly stays the same. But 6% of the household on medical care. Recreation. Fun time. We spend about 6% on recreation. Number 6, education. You guys are spending some money on that right now as we speak. Education and communication. So somehow we put cell phones and learning all in the same category here. 5%. And then we've got other goods. So kind of the miscellaneous other categories got 4%. And then maybe you're wondering what we spend on average on clothing and, in general, apparel. So we can throw some jewelry and other things in there. Apparel runs about 4% as well. All right, so the basket has about 80,000 goods and services in it. 80,000 things are in the basket. So the reason we have this here is to kind of keep in check of, well, what should go in the basket? Not necessarily everything at Walmart is in the basket, right? So we're going to pick things that the average household might be spending their money on. So we can have a lot of things. But as we calculate it, we're going to stick roughly with these percentages so that we're trying to match the out-of-pocket expense that the average consumer has. All right, so let me get rid of this. Any questions there? So, it's kind of interesting how this stuff gets done here. Some of you maybe could go to work for the CPI. How many people like to shop? See a few shoppers out there? Got a few shoppers out there. Well, there's a government employee. There's a government employee with the Bureau of Labor Statistics. So this is calculated by the Bureau of Labor Statistics, is the government department that's responsible for gathering this data. And they send somebody out shopping every month. More likely they're just doing it continuously every day. Their job is to go shopping. So government employee goes shopping. Now notice I don't say buying. What do you sometimes do when you shop? You just look at the prices and comparison check. So they don't do any buying that I'm aware of. They just do shopping and recording of data, right? So government employee goes shopping and records retail prices. And maybe I should put the word full retail prices. If something's on sale that week, you know, they go to Country Mart and it's Campbell's soup and it's 10 cents off today only, they don't record that. So it's just the full retail price that they enter into the database. And they just go to all kinds of stores that the average consumer would go to. So they're literally in our stores recording these prices. Okay, this is done monthly. So Bureau of Labor Statistics, and this is reported monthly to the public. So it's published for all to see. It's reported monthly. Now some of you might be thinking, well, why do we use a basket of goods when we could have all goods and services? I mean, which one's got potentially the right information? All goods and services or a basket, a subset of those? Why do you think a subset?
Because it's what most people will buy as opposed to the...
Okay, so it's identifying the consumer. I'd agree with that. All right. Now, with the other things, if we're looking at all prices, the consumer gets affected by their wages going up too, right? So if the price of the basket goes up, but their paycheck went up too, then all goods and services might have a better reflection of that, right? If we're really trying to capture the average level of prices, there'd be a little bit more data in all goods and services. All right, so why do we use the CPI as the most widely reported source of data? It's for this reason. GDP, when we're gathering data on all goods and services, takes about 6 months at the soonest before they get an early glimpse, 6 to 18 months to get the data on all goods and services. This one's coming out every month. So we don't typically have even a really good idea of GDP until about 6 months out, and then it ends up getting revised anyway. So note, the GDP deflator is probably a better, I say probably because maybe depending on circumstances we want to hone in on the consumer, but in general, if we're really trying to gather inflation data, GDP deflator is probably a better measure of true inflation. But GDP lags, GDP calculations lag real time by about 6 to 18 months. Six months is a half a year. We're a dinosaur in a half a year from now, right? What do you guys imagine with your life 6 months from now? What's it going to be like? What? 6 months, man? I'm just trying to get through this week, right? I'm just trying to get through today. Don't talk to me about 6 months from now. So the state of the economy is in a lot different place. 6 months, obviously 12 months to 18 months. We're in a lot different place. So we want that data a little more timely. And so this ends up being kind of the second best alternative until maybe technology could calculate things faster, which is possible again with today's technology. The NSA is already collecting data on all your phone calls and text messages. Why can't they calculate how many goods we bought, right? It's possible, right? We got Google seems to, or Amazon seems to track all your purchases just fine on the instantaneous when you buy them. Why can't we do it with the other things? I don't know. Technology might get there to where we could start using it and getting data more quickly. But that's the reality at this point in time. Okay, questions or comments on that? All right, so here's the rub. Economists have, I'm going to go back here. There is a discrepancy between the consumer price index and the GDP deflator. In other words, they don't match up perfectly when we reconcile. When we look at the two measures, they're not perfect. So let's just put accuracy here. The CPI and deflator will yield close, but different estimates of inflation. Here's what they found. The CPI tends to be biased upwards 1%. So they find after they've done some studies is that the consumer price index tends to be biased upwards. What the heck does that mean? If there's a bias, first of all, what does bias mean in general? If you're biased towards something or another, what are you doing? You're leaning, you're favoring one way or the other, right? And so we get different results, and the CPI tends to be biased upwards. So is it overstating or understating the actual inflation rate? Overstating. All right. So it is overstating actual inflation, is what that means, to be biased upward 1%. The kicker to that, so kind of the key implication to that, is that a 1% upward bias of CPI leads to a 1% downward bias, a 1% downward bias of real GDP growth. A 1% downward bias of real GDP growth, which we just calculated, right? In our little hypothetical economy, we calculated GDP to be 2.2%. When in reality, if we use the CPI and there was this bias, the way the two kind of work together with how you calculate the index and how you calculate the growth rate, that we'd be understating the actual growth in the economy that way. So those two things work together in that regard. All right, so we want to see why. What are the sources of the bias? Why does it calculate it that way? And that's my cliffhanger for you. We will talk about that on Wednesday.